I want you to try and cast your mind back to 2017, if you can. Think about what tech news you were actually paying attention to back then.
Oh, man. I mean, it was probably all the breathless coverage of quantum computing, right?
There, exactly. It was,
Hmm.
subatomic particles, unfathomable processing speeds. It was everywhere.
Yeah, everyone was screaming that it was going to be this total revolution in human capability.
But meanwhile, the actual revolution, the one that would completely rewrite human history over the next 9 years, was, it was just quietly sitting there.
Hidden in plain sight, basically.
Yeah, published in a PDF document with a title that honestly sounded more like a Beatles song than a scientific breakthrough.
It really did.
So today we are doing a deep dive into a phenomenal new piece that just dropped this morning, May 26, 2026. It's in Tech Reader magazine by Aaron Rose, and it's titled The 9 Years That Changed Everything.
It is a fantastic read. Highly recommend it.
Yeah, our mission today is to map out this invisible journey. We want to look at how AI went from this quiet, almost philosophical-sounding research paper to the absolute foundational infrastructure of your daily life.
Because the speed of that transition is just staggering when you actually look back at it.
It really is. We're going to figure out how this happened so incredibly fast and what the mechanics behind it actually look like. Okay, let's unpack this.
Well, to really understand it, we do have to start with that quiet PDF document. Because, as Aaron Rose points out in the piece, the AI era didn't begin with like a massive product launch.
Right, there was no Steve Jobs moment.
Exactly. No keynote speech, no ribbon cutting. It was completely invisible to the general public. It all started with a 2017 research paper from a team at Google Brain called Attention is All You Need.
Which is the Beatles-sounding title.
Right. And while that title sounds very poetic, what it actually did was introduce a totally new kind of neural network architecture for processing language. And they called it the transformer.
And I was trying to visualize the sheer scale of the upgrade this transformer represented. Because to understand why it was such a seismic shift, you kind of have to understand how machines used to read text before 2017.
Oh, yeah. The old sequential model.
Right. So imagine you're trying to read a deeply complex, dense novel, but you are forced to read it through a tiny sliding peephole.
That sounds miserable.
It is.
Yeah.
You can only see like one syllable at a time, and you have to move this peephole strictly left to right across the page.
Right. And the problem with that is digital amnesia.
Exactly. By the time your little peephole reaches the end of a long, complicated sentence, you've completely lost the context of how the sentence even started.
Yeah, that peephole metaphor perfectly captures the fatal limitation of the old way AI processed language. It was computationally so slow, and it just couldn't handle complex reasoning.
Because it couldn't hold the whole picture in its head.
Precisely. It didn't have the operational memory. But then the transformer architecture arrives and essentially just shatters that peephole.
It just breaks the whole thing open.
Exactly. The machine stops reading sequentially. It begins reading in parallel. So suddenly it can look at the entire page, the entire document all at once.
But wait, how does it actually do that? Like, how does a machine look at a whole document simultaneously without just immediately getting overwhelmed by all that data?
Well, it relies on a mechanism they introduced in the paper called self-attention.
Okay.
Instead of just reading words in a strict order, this self-attention mechanism assigns a mathematical a score of relevance between every single word in a sentence and every other word simultaneously.
Oh, wow. So it's looking at everything in relation to everything else.
Right. So if it reads the word bank, it instantly looks at the rest of the paragraph to see if words like river or money are nearby, just to determine the exact context.
So it builds this massive multi-dimensional web of relationships instantly.
Exactly. It holds the entire context in its mind all at once.
So the researchers at Google Brain essentially built the engine, like the internal combustion engine, that everything we use today would eventually run on.
They absolutely did.
Yet, to the public in 2017, literally nobody cared. I mean, the media was still completely obsessed with quantum supremacy.
Yeah, but what's fascinating here is that inside the research labs, the atmosphere was completely electric. I mean, they knew what they had.
The water was already rising.
Yes. And this is where we see the quiet founding of OpenAI. They actually started as a nonprofit back in 2015, backed by, all these Silicon Valley heavyweights.
Elon Musk, Sam Altman.
Right. And they eventually transitioned into this capped profit structure. But they took this open source transformer engine that Google had just published, and they started quietly feeding it staggering amounts of data.
Which brings up a term we hear literally constantly but rarely ever define. GPT.
Ah, yes.
Generative pre-trained transformer. Now, I think transformer makes sense to us now, thanks to the peephole analogy. But what does the pre-trained part actually mean in a way that, matters to you listening at home?
Well, pre-training is basically the brute force phase of building an AI.
Okay, brute force how?
So before you can ask a model to write a poem or debug your software code, it has to understand the fundamental patterns of human logic and language first.
Right.
So researchers scrape a massive portion of the public internet. We're talking books, articles, Wikipedia, random forums, and they just feed it all into the neural network.
So it's basically reading the whole internet.
Kind of, but the AI isn't memorizing facts like an encyclopedia. It's playing this trillion-round game of guess the next word.
Well, like autocomplete on steroids.
Exactly. And through sheer repetition and unimaginable scale, it naturally learns grammar, facts, reasoning, and context. It gets pre-trained on human knowledge before you ever even interact with it.
Wow. So OpenAI just keeps iterating on this engine. We get GPT-1 in 2018, then GPT-2 in 2019, which caused a bit of a murmur in the tech community, right?
Yeah, because OpenAI actually refused to release the full model of GPT-2 initially. They cited fears that it was too good and could generate convincing misinformation.
Which sounded like PR hype at the time, but then the real shockwave hit the research community in mid-2020.
The pandemic era.
Right. Everyone is locked inside, and OpenAI drops GPT-3.
And the capabilities of GPT-3 were just staggering for that time. I mean, researchers were watching the system do things it was never explicitly programmed to do.
Like what?
It was translating obscure languages, it was writing functional software code, drafting these incredibly compelling essays.
It was incredibly powerful. But, as Aaron details in the article, it had a fatal flaw.
Yes, the hallucinations.
It would hallucinate facts with terrifying, absolute confidence. I mean, it would just fabricate historical figures or invent legal precedents out of thin air.
And it would use the exact same authoritative, factual tone as it used for real information.
Well,
it was wild.
So at that point in 2020, it really remained a tool strictly for developers. You needed the technical chops to navigate how unreliable it was.
Which highlights this really fascinating historical pattern. Having a revolutionary engine sitting in a laboratory doesn't change the world if there's no steering wheel for the general public.
Oh, I love that. A steering wheel.
Yeah. And the steering wheel for this entire era arrived on a very specific date, November 30th, 2022.
The launch of ChatGPT.
Exactly.
And what's crazy is that OpenAI honestly expected it to be this modest, quiet release. They literally labeled it a research preview on the website just to gather feedback on conversational dynamics.
They had no idea what was about to happen.
None. Instead, they triggered literally one of the most explosive consumer product adoptions in human history.
The numbers are still hard to wrap my head around.
Let me just read the specific metrics from the source because they're insane. 1 million users in 5 days. 100 million users in 2 months.
Unprecedented.
To put that scale into perspective for you listening, it took TikTok 9 months to hit 100 million users. It took Instagram 2.5 years. ChatGPT did it in 8 weeks.
The adoption curve wasn't a curve, it was just a vertical line.
Wait, hold on. Let me push back on this a little
Sure.
bit, make sure I'm picturing this correctly. If the underlying engine inside that initial version of ChatGPT was essentially just the same GPT-3 technology that developers had already been playing with for over 2 years,
Which it was.
then why did it completely explode? Was the AI actually that much smarter overnight?
No, it wasn't, and that's the crucial point. The revolution in November 2022 was not algorithmic. It wasn't about the tech getting suddenly brilliant. It was the interface.
The steering wheel.
Right. Before ChatGPT, interacting with an AI meant querying an API. And an API is essentially this invisible digital bridge that developers use to make two pieces of software talk.
Right, and you needed to know how to write code to cross that bridge.
Exactly. You had to be a programmer. But with ChatGPT, the barrier to entry dropped to absolute zero.
Because they made plain English the most powerful programming language on Earth.
Precisely. You didn't need to know Python or C++S. You just typed a question into a chat box that looked like iMessage.
You could ask for like a 5-year-old explanation of why the sky is blue.
Or you could paste in a dense medical diagnosis and say, hey, remove the jargon for me. And it would respond patiently and coherently at 3 in the morning.
It took this massive, invisible, cloud-based infrastructure and literally just dropped it directly onto your living room couch.
Yeah, and because plain English became the ultimate programming language, every major tech giant suddenly woke up in a cold sweat.
They realized their massive, complex platforms were incredibly vulnerable to this zero-friction interface.
And this triggers an absolute corporate panic in early 2023. I mean, look at Google.
Google, arguably the company that invented this entire field with that 2017 Transformer paper, they realized they'd been caught completely flat-footed.
It is a textbook case of the innovator's dilemma.
How so?
Well, Google had these massive, incredibly smart language models sitting securely inside their own walls for years, but they were terrified to release them because AI threatened their core search business model.
Right, like why click on 10 blue links and look at advertisements if an AI just gives you the exact answer instantly in one paragraph?
Exactly. It would cannibalize their own revenue. But the sheer cultural pressure of ChatGPT forced them to rush out their own chatbot, Bard, in February 2023.
And it was a total disaster.
Oh, it was brutal.
They released this highly polished promotional video on Twitter, and someone asked Bard a question about the James Webb Space Telescope. And the AI confidently provided a factually incorrect answer.
In the pre-recorded promotional video, they didn't even catch it.
The stock market wiped out tens of billions of dollars in Google's value in a single day. Just gone.
And the severity of that market reaction really cemented a crucial lesson across the entire industry. Releasing an AI product before that hallucination problem is solved carries astronomical reputational and financial risk.
Yeah, the stakes became very real, very fast. And here's where it gets really interesting.
Oh, the splinter.
Yes, because the industry didn't just blindly race each other for raw processing speed after the Bard incident, they completely splintered. The leading labs started taking radically different philosophical bets on what an artificial intelligence should actually be.
Because they realized they weren't just building calculators anymore, they were building synthetic personalities.
Right, and we see four distinct design philosophies emerge almost simultaneously. Take Anthropic, for instance.
Right, Anthropic. Founded by Dario and Daniela Amadei.
Who actually defected from OpenAI because they were super concerned about safety.
Exactly. So their philosophical bet was entirely on safety and honesty. They built a model called Claude. But, more importantly, they pioneered this new mechanism called constitutional AI.
Which sounds crazy. Like, how do you actually program a moral compass into a machine that just predicts the next word?
Well, you don't hard-code it line by line. Instead, Anthropic gave the model a literal constitution, a text document of foundational principles drawn from things like the UN Declaration of Human Rights.
Okay.
And during the training phase, they forced the AI to grade its own generated responses against that constitution and rewrite any answers that violated the rules.
Wait, really? So they automated the ethical training process?
They totally automated it, creating an AI that fundamentally prioritizes harmlessness over just being helpful.
Wow. But then you look at the complete opposite end of the spectrum with a company like Inflection AI.
Right, co-founded by Reid Hoffman from LinkedIn.
They released a model called Pi, which stood for personal intelligence. And Pi wasn't designed to, like, ace the bar exam or write complex Python scripts.
No, its architecture was tuned almost entirely for emotional quotient, EQ over IQ.
They optimized the model for patience, empathy, conversational warmth. They basically bet that what isolated modern humans really wanted wasn't a supercalculator. They wanted a companion.
Yeah, a listener. Meanwhile, the incumbent giants were playing a completely different game. Look at Microsoft.
Right, who had poured billions of dollars into OpenAI by this point.
Microsoft decided their philosophy was ubiquity. They didn't want you to have to visit a special AI website to use it.
Right, they just integrated the GPT-4 engine directly into the daily infrastructure of the corporate world.
Copilot. They embedded it into Word, Excel, Outlook.
They basically turned the AI from a novelty toy into the invisible background hum of the modern office.
Exactly. But then Meta Mark Zuckerberg's company decides to just blow the doors off the entire walled garden.
They release a llama, and they make it open source.
And that open source maneuver fundamentally shifted the global power dynamic of AI.
Because instead of requiring developers to, pay Microsoft or OpenAI a toll every time they wanted to ask an AI a question through a locked API, Meta essentially just published the raw blueprints.
They handed the schematics to run world-class intelligence locally on their own hardware.
So a developer in a garage in Estonia could just build their own custom intelligence factory on a specialized laptop.
And once those blueprints were out there, that deeply held assumption that only a massive Silicon Valley monopoly could afford to build these things, it completely collapsed.
It catapults us directly into the massive disruption that defined 2024 and 2025 because the technology stopped being a fun chat interface and quickly evolved into cheap, globally distributed infrastructure.
Yeah, the DeepSeek shockwave.
Right. Aaron Rose's article highlights this huge moment. DeepSeek, a Chinese research lab, suddenly releases models that match or outright beat the leading Western models.
And the terrifying part for Silicon Valley was that DeepSeek did it at a microscopic fraction of the cost.
The DeepSeek moment proved that algorithmic elegance can actually outmaneuver brute force computing power.
Which totally flipped the script. Up until then, the prevailing wisdom was just whoever bought the most NVIDIA microchips would automatically win the AI race.
Right, just throw money and servers at it.
But DeepSeek optimized their architecture so intensely. They used techniques where only specific, highly specialized parts of the AI's brain activated for any given query.
So it wasn't running the whole engine just to answer a simple question.
Exactly, and that drastically cut the computational cost of training. It proved the race was truly globally competitive and that the barrier to creating Tier 1 intelligence was just plummeting.
And as the intelligence got cheaper and more widely distributed, the fundamental nature of what we actually asked it to do shifted. And this is the major pivot from 2025 into 2026 that defines where we are sitting today.
The shift to agents.
We transitioned from chatbots to agentic AI.
And the distinction there is critical. It is the difference between asking a system a question and giving a system a job.
Right, because a chatbot is entirely passive. You ask it for a dinner recipe, it generates text, and then it just waits for you to talk again.
But an agentic AI is active. It's autonomous.
The article points to tools like Anthropic's Claude Code. It doesn't just act as a glorified autocorrect for a programmer anymore.
No, an agent can read an entire massive corporate code base. It can understand the architecture, independently identify a deep security vulnerability, propose the fix, and then actually implement that fix across multiple files on its own.
Or look at OpenAI's operator, which was engineered to navigate web browsers autonomously.
Right. You aren't guiding its hand step by step. You just provide a high-level destination, and the agent takes the wheel.
It clicks, it scrolls, it reads text, fills out forms, navigates cookie pop-ups independently, and it only reports back to you when the final task is totally completed.
And imagine the real-world application of this in medicine, which the article touches on beautifully.
Oh, the MRI example.
Yes, an agentic AI doesn't just look at an MRI and flag a potential tumor. It automatically cross-references that finding against the patient's entire 10-year medical history.
It checks their specific insurance coverage for the necessary biopsy.
It drafts the referral email to the specialist.
It queues up the scheduling system. And it does all of this before the human doctor even walks into the exam room to deliver the news.
The blur between AI as a software tool and AI as an active autonomous participant in your workflow has just completely dissolved.
It's gone. And the reality inside major corporations today reflects this. I mean, the enterprise adoption landscape in 2026 is entirely distinct from that massive ChatGPT frenzy of just a few years ago.
Because companies aren't loyal to one brand anymore.
No, they've built intelligent routers into their IT systems. If an employee asks a really complex math question, the system silently routes it to an OpenAI model.
If they ask a creative writing question, it silently routes it to Anthropic's Claude.
And if it's just a basic data sorting task, it uses a free open source meta model. The actual brand name of the AI has become completely invisible to the end user.
The technology has just become capable enough, reliable enough, and cheap enough to simply fade into the background architecture of the economy, like electricity.
So what does this all mean? We have journeyed from a completely ignored scientific paper in 2017 all the way to autonomous agents drafting legal briefs and running corporate workflows in 2026. Where does that actually leave us today?
Well, Aaron Rose offers a deeply resonant reflection at the end of his piece. He admits, he isn't a machine learning engineer.
Right.
He didn't read that paper on transformers back in 2017 and predict the future. He experienced this revolution the exact same way most of the public did.
Gradually and then suddenly all at once.
Ex-
He compares living through this era to building a house next to a river. He says the water had been steadily rising for years, fueled by massive investments and these quiet, algorithmic breakthroughs.
But nobody noticed how high the water had actually gotten until the floodwaters breached the living room in 2022.
And that gap in awareness is the defining fault line of our era.
It absolutely is. The disconnect between the researchers who understood the mathematical power of self-attention 9 years ago and the broader public who were just suddenly splashed by these highly capable chatbots.
The AI era fundamentally snuck up on us. It snuck up on our legal systems, our educational institutions, our governments.
Which means the narrative in 2026 has fundamentally shifted. It is no longer a story about capability. We know these models are capable.
They are blowing past the developmental timelines that almost every expert predicted.
Right, so the story we are left with now is entirely about governance.
Who actually decides what these autonomous agents are allowed to do?
Under what ethical constraints do they operate? Who audits their decision-making process when they say, deny a small business loan or misdiagnose a patient?
And ultimately, who is held accountable?
These are no longer computer science problems. They are the most pressing legal and societal questions of our generation.
And we are currently trying to build the airplane while we are flying it. We're living inside a global economy that was entirely rewritten by an invisible idea. Which leads me to the final provocative thought that I want you to mull over today. Think about the tools you rely on right now. The invisible agents sorting your emails, analyzing your data, and running the background processes of your life. If the last 9 years took us from a quiet, completely ignored PDF document to autonomous agents running the modern corporate world, what invisible research paper is sitting quietly on the internet today, completely ignored by all of us, that will completely rewrite your life by 2035?